Hi, welcome to Modra Technology. I'm Tim Modra. I'm proud to give you a presentation of our creel automation system. This is our full production version of our 4-robot 12 spindle system, and I'm going to give you a presentation interspersed with running of the machine. I'll give you a description of how the machine works as well. So first of all, let's go to the machine. And what we have here is 2 mobile creels inside our machine and 4 robots. Each robot actually loads packages on the face of each of the mobile creels, and the robots actually then have access to a winder, which is a stack of 3 spindles. Very quickly, Modra Technology has been involved in technology for the soft flooring industry for about 30 years now. We developed a sample machine called the Kibby. We developed a tufted sample machine called the M-Tuft, and we've made various versions of that, faster ones and cheaper ones. We've made machines for rug production and also done some work in robotics and automation for the carpet industry as well. Modra has sales in many countries around the world, 40 countries, 150 customers, and over 400 machines. And 3 or 4 years ago, Modra looked at our product range and thought we really want to explore the needs in the industry, and people were saying creel automation for tufted carpet is a real pain. So we've invested a lot of product development time for the last 4 years on looking at creel automation, and the CreelMT is the result of that. So whenever we start a new project, we carefully define the problem, and the problem here is around the preparation of yarn for tufting machines. Modern tufting machines have a demand for precise lengths if we're not to waste yarn, and also the creativity means that there can be a variation in thread ups and lots of colours and lots of complex thread ups as well. And then there's labour associated with regular yarn preparation and creeling, and for modern tufting machines, the labour could be even higher. So if there's opportunities to lessen that, make that, to lessen the labour associated with it, that would be a great benefit. And that's what we've done with CreelMT. So CreelMT is, as I said, a mobile creel in the middle here, a robot on the side, and a winder of 3 spindles here. And how it works, we have a mobile creel which we've created ourselves, maybe 250 positions. That's customer definable. Each position is 1,000 grams maximum, 2.2 pounds. And we've worked with Gilboss to develop this stack of spindles, and it is capable of 1,000 meters per minute. And you might normal way to do it might be to store empty cores in this winder, but we said no. Uniquely, we bring the empty cores in with the mobile creel. So the empty cores are stored in the mobile creel. The empty cores are part of a circular system then. So the first step is to extract the empty core from the mobile creel, place the empty core into the winder, then take the wound package out and put it back into the same position. We also start the winder with empty cores, so we actually have a small buffer in the winder. The winder is preparing the next package as the empty is put in there. Also, the winder has a creel of packages behind it. Each winder position, each spindle position has a swing out creel, 2 positions, a used one and a backup one supplying yarn, and they may all be the same colour yarns or maybe different yarns. You'll see this front robot now picking up a wound package, placing the wound package, blowing through the yarn, locating the next position, extracting the empty core into the spindle position. Now remember, there was one empty core in there being wound, so the wound package is immediately available. Wound package picked up and positioned where we extracted the empty core. And remember, we can wind, our spindles are actually controlled length, measured length, so we can wind any length up to 1,000 grams of yarn and also our software dictates and determines what colours we're picking from there, so any length and any colour. So the benefits of a system like this are its flexibility. We can actually choose a combination of robots and spindles to match the customer needs and match the tufting machine needs. Immediately we have tremendous benefits for short runs. Our labour of placing the packages in the creel has gone. We have tremendous labour saving not only in the creel but also in how we arrange the winding of packages. We have opportunities for great waste reduction. We also give the opportunity to splice more efficiency. We have a system of beam splicing then available from these mobile creels. That alone can actually improve our tufter overall equipment effectiveness. And we will have better quality of yarn because we have less knots and less splices in the creel and also through the needles. Our machinery also, compared to a fixed creel, takes up much less area. Some other features are safety and ease of use. So, flexibility. We have the opportunity to have many configurations of robot and winders. Our smallest system is a 1 robot 3 spindle system, as indicated by these. So we have the winder, the creel associated with the winder, and a robot and a single mobile creel in our CreelMT system. In this configuration, we would extract the mobile creel and turn it round to do the other side. 2 robots and 6 spindles would look like this, and then straight away we have a robot on either face of our mobile creel. 2 robots and 12 spindles would be like this. 4 robots and 12 spindles looks like this, and that's the configuration that you see in front of us here running. That's the, this is the 4 robots, 12 spindles operating on 2 mobile creels. And then our very large system is 4 robots and 24 spindles, which is the layout you see here. So the question is then, how do you decide which configuration suits your needs? I'll explain it by considering a scenario where we have 1,000 needles, and I'm just thinking about the robot and the winder, how they work together. So our total cycle time for our robot is about 23 or 24 seconds. We use the number 25 seconds. So for 1 robot, 25 seconds is 6.9 hours. If you only have 1 robot, it takes 6.9 hours to do 1,000 positions, 1,000 packages. 2 robots is half that time, 4 robots is a quarter of that time. The winders, if you have a single stack of 3 spindles, it takes a long time to wind the yarn for any reasonable length of carpet. 6 spindles decreases that time for the particular job. 12 spindles is there and 24 spindles would be there. Because our robot and our winders are working sequentially, one after the other, whichever is the lower of these 2 times sets the performance curve of our system. So this curve here is the performance of our 1 robot 3 spindle system. For very, very small runs here, we are dictated by the robot's performance, and as the speed gets up, we're dictated by the performance of the winders in this area here. This one is 12 spindles and 4 robots. This one is 4 robots and 24 spindles, the characteristic curve. So the way we look at it, the way we make a decision on what configuration is to say, here's the performance of a particular tufter. Let's work out where we can plot a line on these characteristic curves to just be a little bit faster than the tufter. So you'll notice here, down here, our robots again are a little bit slower than the tufter would be at this very small carpet length. Up here, our winders can produce the required yarn for that tufter's performance faster. That's important because our tufter as I said before, with our beam splicing, we may actually improve our OEE on the tufter. So we should have a CreelMT performance faster. Here's another scenario with a tufter, we'll call it tufter 2, and the performance curve that suits that might be a 4-robot 24 spindle system. And we provide this information with much more detail, and we can look at the yarn, ratio of the yarn length to the carpet length, the number of spindles, the number of robots, number of needles, the tufting machine RPM and stitch rate and OEE, and generate this characteristic curve, which is exactly the same curve here. There's the tufter performance in orange, there's the tufter performance in orange, and the CreelMT performance in blue there and there. So from this curve, you can actually experiment with different configurations and work out which is the best scenario, which is the best ratio of robots and spindles to best suit your needs. Now, we don't have to make CreelMT suit one tufting machine, but it's a handy way to do it when you're considering the first system. When there's lots of CreelMTs and lots of tufters, they can be actually decoupled from each other, and two CreelMT systems can be supplying the yarn for a tufting machine which may be running at more shifts than the CreelMT, for example. We can mix and match into the future with different numbers of CreelMT and different numbers of tufting machines. As I spoke before, these numbers here in this area here, our CreelMT system is a little slower than the tufter performance, but remember, we have no labour in the creel for this, so this is still very fast for a carpet length of 100 metres. Here's some other typical small runs there as well, under 3 hours for 200 metres, and under 4 hours for a carpet length of 300 metres. Okay, let's compare conventional creeling and the labour associated with that for a normal variable draw tufting to CreelMT. So what I'm going to describe will be a summary of lots of different scenarios. Some of these might be the same as what you do, it may be different, but this is an overall view of conventional creeling. We bring multiple packages to a winder and we prepare packages. We make them an approximate size, take them to the creel, place the packages in the creel on a 2-position creel, and when the tufting machine is ready for changeover, we actually splice in those packages. So then when we're finished, at the time when that's running, we remove the cores that have some remnant yarn. When the remnant yarn gets down to 10%, we may describe that and we may scrap that yarn. Also, there's paper cores on there, and those paper cores would be scrapped as well. Or if the yarn, if we want to, we back wind and bit wind and put the yarn back into stock. The labour associated here might be 4 hours on the winder, and it could be one person for a simple job, or 2 or 3 people for a very complex thread up where there's a necessity to change a lot of colours. The labour here to place the yarns may be 20 man-hours, to splice in the creel may be 2 hours, and for this experiment, for this demonstration, we'll just talk about a tufter run of 2 hours. And the back winding and bit winding is really hard to determine. It depends on how much yarn, if you decide to, and how much yarn that you want to put back into stock as well. So there's 2 types of effort here. There's a variable effort, meaning that effort changes with the job size, and there's fixed effort. This fixed effort doesn't change. For a small run or a large run, you still have to place individual packages in the creel. You still have to splice every one. Those numbers are fixed. They are the problem numbers in conventional creeling. Let's compare it to CreelMT. CreelMT, we have, you may consider CreelMT as actually an automated winding system that automatically puts packages in a creel. We bring packages there and we take the prepared mobile creels to the tufting machine. When ready, we beam splice the whole system in and run the tufter. Our scrap, we believe our scrap will be around 2%. The cores remain, remember the cores remain in the mobile creels. Also, I'll stress that the cores are plastic cores. They are much more durable than paper cores. They stay in the system again and again and again and are not damaged by the system. So times here, our times here, the time is easier, the machine is faster than, depending on the loading and the number of people you put on the winder, but we'll say 3 hours and one person controlling the CreelMT. 1 hour for beam splicing. Our variable effort is a little bit less. But the big change is our fixed effort in placing packages in the creel. That is totally eliminated. That's our big saving with CreelMT. We have 50% effort at beam splicing as well. So, short runs, we've almost eliminated the fixed effort. The labour of the two approaches, 26 hours versus 4 hours. Our waste is reduced from 10% to 2%. Our OEE, in this example, our OEE is related to what's the downtime for splicing compared to the run time for the tufting machine. Our OEE goes from potentially 50% to 66%. Our quality, because our yarn is going one pass through, it's not going back into stock. Yarn that goes back into stock and is rewound and spliced or knotted causes its own problems. Our system is one pass through the whole system. It'll increase the quality at both in the creels and increase the quality and better performance in the tufter. Our creel tension will be reduced, and also our area of operation is reduced as well. Maybe we're only 50% of a fixed creel area. Safety. We enclose the whole machine in a safety cage. That's our primary safety approach to this machine. Anything that's high velocity or high energy is protected from the operators by a safety cage. We have e-stops on the cage and the winders. We have gates on either end of our system, and the gates actually have safety switches on the doors, and we actually have a safety reset process. Here we have lockouts on the power and air, and that prevents anything happening if the operator's if there's maintenance being done on our system. Ease of use. We've spent a lot of time working it out to make this system easy to use. Our input to our machine is Excel, a simple Excel sheet with needles, thread ups, and the length of yarn per position. We have a very sophisticated operator interface at our creels, directing the operators who are loading yarn into the winder creels what packages of what yarn to use throughout the whole process of loading creels. And also we have a burn-in process because we have yarn all collected into header strips. We have the opportunity to treat this as a beam and burn in the yarns very quickly into the tufting machine. So thanks for the opportunity to share. We have more videos on our website. Please contact us if you want more explanation about our CreelMT system. Thank you.